Okay, good morning, everybody, and welcome to this talk about implicits in Scala 3. I believe introductions are in order first. My name is Ayush Mittal. I work as an IT chapter lead for ING Bank in Netherlands. Me and my team are building the world's biggest digital and programmable contact center. We use Scala in almost all our APIs and libraries. If you want to know more about my work or if you want to work for us, please contact me after the talk or using these details. So for this talk, the goal of this talk is to look at how implicits work in Scala 3. But to really appreciate the Scala 3 changes, we must take a look back. We must look back at implicits in Scala 2. We want to see how good they were, but we also want to see what went wrong with them. So there will be a 5-minute rant about what was wrong with implicits in Scala 2. And then finally, we will look at future and how Scala 3 is trying to change those controversies. So the good things first about implicits in Scala 2. So Scala 2 implicits or implicits in Scala are a widely used feature. All of us have come across them directly or indirectly. They are behind some of the most well-known design patterns that we use every day. I want to list a couple of those patterns. The first pattern that is powered by implicits is the late trait implementation pattern. And this is the original reason why implicits were there in Scala. So the idea of this pattern is that you want to implement a trait in an existing class. And for that, you would use an implicit keyword. So for example, in this snippet, you're seeing that to the string class, we are adding the order trait. And this is the original reason why we had implicits in Scala in the first place. The other well-known pattern that is powered by implicits is the extension methods or the pimp my library methods. So extension methods allow you to add new methods to existing classes. In this example, what I am doing is I'm adding a method called unzip to an option of a tuple. And this is also a pattern widely used in many Scala libraries. Last but not the least, type classes, very powerful, very well known. Again, this entire feature of type classes in Scala is powered by implicits. And the idea is, here I have a snippet from cats, where you see the type class monoid, and you see the implementations there, and it's all powered by implicits again. So there are many more. I don't want to go into details because they are well known. Type safety, dependency injection, they're all working well in Scala. We all use them because of the feature of implicits. However, the feature is so powerful, and it's so easy to use that it is also quite often misused. And that misuse generates a lot of anti-patterns, a lot of difficulties. Again, many of you might know of these, so I want to highlight the top 2 that I think are most controversial. The first controversial thing about implicits in Scala 2 is implicit conversions. Implicit conversions are pure evil, if you ask me. They always result in unexpected results, and they're not good. If you see implicit conversions, especially from A to B and B to A, it's really not a good idea. Here is an example. You see that there is an import of an implicit conversion from the collections library. I have a case class employee, which has a property name, and then I create a map of employee and age. So the key of my map is the employee case class. But what I can perfectly do is I can do a get on a string here. And that compiles perfectly fine, but produces null. And that is because the implicit conversion in scope there is converting my Scala map to Java map automatically and allowing me to do the get call. So this sort of implicit conversion was root cause of many performance issues when they were really introduced in the beginning. The other thing about implicits which is not so good is their misuse. And this time I'll take an example from a Stack Overflow post that I found. So some user who had this question on Stack Overflow, He said that he had a case class person, which had some mandatory fields and some optional fields. As you can see, the middle name is an optional field. And then he was like, why does the first line does not work? I mean, I should be able to pass K, and Scala compiler is so intelligent. It should automatically convert that K to a sum of K. I mean, that boilerplate should go away. And so he knew implicits, so he thought, okay, why don't I write an implicit conversion from a T to an option of T? Yeah, he did that. It worked, and it does work. But what he didn't think is there's so many other things, so many other bad things that this implicit conversion will bring into picture. His problem, that he didn't want to write that sum of K, and he wanted automatic conversion from K to sum of K. He could have solved using an overloaded apply method. That was his solution. But because he knew implicits, he went for the implicit solution. And the saying is that if you have a hammer, then everything looks like a nail to you. So if you know implicits, bang, use them everywhere possible. So that is what I meant by misuse. Implicits were really misused in terms of implicit conversions. And that brings to the most unpleasant part about having them in Scala is because there is just one keyword implicit, whether it's a good practice you are doing or a bad practice, the keyword is same. It's implicit everywhere, classes, defs, parameters. And that made it really hard for beginners to get a grasp of things. I could call this title, Why Senior Management Does Not Like Scala, because it's really hard to learn. You don't get, for companies with thousands of employees, it's really a steep learning curve. And then if the learning is difficult, then adoption is really difficult. So yeah, this was one thing that really did not help in terms of how it was working. And because it was so controversial and so unpleasant, there is an example just to highlight that difficult in learning curve. There are two methods here, method 1 and 2. The first method is an implicit, conditional implicit. It takes a conditional implicit value. It's a good practice, and it is used for type class pattern, the method 1. Method 2 is an implicit conversion. It looks dubious. It is easy to do. And for a beginner in Scala, method 1 and 2 looks the same to him. He cannot figure out what's good and what's bad. The only thing beginners will figure out is what is easy to do, and it is method 2, so they will choose the method 2 here. So that's what I meant, that this single keyword with all its good and bad use cases is making things difficult for adoption purposes and for learning purposes. So because of these issues, Scala 3 designers, they came up with some fundamental changes, and the goal is to make the language more easier to learn, more accessible to everybody. And I think implicits was a good place to basically do some redesign. So the goal of these changes that we will see is to make the language easier to learn and harder to abuse, and not the vice versa. So the changes that we have in Scala 3 around implicits or around contextual abstractions are around 3 main categories. The first one is about extension methods that are new in Scala. The second one is about using clauses. And the third one is about given instances. So there are 3 different use cases that you might have. And for these 3 use cases, there are 3 different syntax and 3 different keywords to use. So that's really a good step, right? There's not just one keyword where you have to use for everything. There are 3 different syntaxes and keywords for different use cases. So let's look at these 3 different syntaxes and use cases in details. The first one is the built-in support for extension methods. So extension methods allow you to add a method to a type after the type is defined. And it's really helpful in reducing boilerplate, writing verbose and easy to read code. So Scala 3 has native and inbuilt support for this. The keyword that you have to use is called extension. It's a new keyword. In this example that you see here, we are adding a new method to a type which is a list of int. The method is called has duplicates, and it basically is checking if the list has duplicate elements or not. And at the call side, you can see that it feels like the method is inbuilt inside the list class, which is really what it is all about: verbosity, easy to read, and easy to understand. So this is a new thing in Scala 3 with extension methods having direct support. The good thing about extension methods is also that they can be parameterized and they can be grouped. So you can parameterize them, as is done in the example with the parameter type t. And you can group them, so you can have multiple extension methods written. In this example, I have 3 methods which do some utilities like check duplicates, check for palindrome, and find the smallest value in the list. You can also see that even passing implicit values to the methods is allowed. So that's also a good thing. So the extension keyword with its nice syntax is really a handy feature to have. The second major change with implicits or contextual abstractions in Scala 3 is about the using clause. The using clause correspond largely to how we had implicit parameters in Scala 2. It's a new terminology, like many things. They are referred to as context parameters, and the list is known as a using clause list. So in Scala 2, you had implicit parameters, and in Scala 3, you have using clause. But of course, it's not a like-to-like change. There are improvements in Scala 3. And let's look at that improvement. The first biggest improvement is that you can have more than one using clause, and you can anonymize them. And what I mean by that is, if you look at the example, I have a domain class worker, and I have a method called assign task. The method assign task has multiple parameter list. The first parameter list is a normal one. The second one is a context parameter or an implicit parameter with the using clause. And the parameter is anonymized, it doesn't have a name. The third parameter list has 2 parameters, and they are both named. So this is nice. You can add multiple using clauses. You can not name them if you want. And at the call side, if you see, we can call them multiple ways. We can pass all the context parameters if we want, or we can pass some of them or none of them. So at the call side also, the usage is quite consistent and orthogonal. The other big advantage of using clause over implicit parameter is in terms of clarity. In Scala 2, implicit parameters had some unclarity, and here is an example of that. If you look at this method foo, I'm passing it 2 parameters, integer and a string. And the question is that how is the second parameter defined in this method? Is it an implicit or is it not an implicit? Anyone want to take a guess? Yeah.
It's not.
It's not.
Because string should never be implicitly.
Okay. We have someone who's really core to the design and philosophical, but philosophy aside, it could be both ways. You can have the method foo defined in both ways. It could be a normal parameter, it could be an implicit parameter. And at the call side, by looking at the call, it's not easy to tell whether the string passed is implicit or not. It's passed like a normal parameter. There's no difference between implicit and non-implicit. It's all the same. And this could have been a source of confusion, and you have to really understand, for people who want to learn this language as a new language, this is not really nice to see. This changes in Scala 3 with the using clause. So if you want to provide a context parameter explicitly, then the using keyword is a must. And what I mean by that is that if I have the method foo again, and the second parameter is a context parameter, if I have to pass it explicitly, then I have to use the keyword using at the call side. So if I look at that call, then I am very clear that the parameter John is passed as a context parameter and is an implicit here. So this adds clarity to the code. Also, another add-on to this advantage of clarity is about removing ambiguity. And let's look at another example from Scala 2 implicit keyword. So we have a method here called getMap, which takes an implicit parameter config and returns a map. Now, we have an implicit in scope, a valid implicit. So when I call the map method and I try to fetch a value from the key, so I'm passing the value 47 to the map, assuming that I'm passing this as an apply to the map method. But that's not what the compiler has thought about it. The compiler has taken the integer 47 as an explicit argument to the config parameter. And compiler has totally misunderstood our intentions. It is thinking that we are passing int as an explicit parameter to the config, which is never the use case. So the workaround these things is that you have to write getMap and then apply to get the value out of the map, which is, again, not regular, awkward, and not orthogonal. So this ambiguity is resolved with the using keyword. If you have the using keyword, because there can be many of them and because they have a different syntax, if you want to pass them explicitly, that same problem does not come with Scala 3. So here, the compiler pretty well understands that you want to use the implicit in scope for the config, and the integer is passed to the map apply method, so it works fine. So the using keyword is a replacement for implicit parameters, but has some improvements and some important improvements over the Scala 2 variant. The next one is, and the most important change around implicits in Scala 3 is about given instances. And if we talk about given instances basically replace implicit definitions. So in Scala 2, you could do implicit def, implicit val, and implicit classes. That all gets replaced by the keyword given. So the given is the new way to define terms that can be synthesized, or basically implicit definitions. And again, the core idea is that you have a different keyword for different use case. So if I show you an example of how it works, here I have defined 2 implicit definitions using the keyword given. There is a dev config, and there is a config without any name. So given instances can be anonymous as well. A note here that given instances are lazy val by default, which might be a surprise to some with Scala background. So why are givens lazy val? But a topic for some other discussion. But this is how you define given instances. You can also see how they are being used at the call site. Now, how have they improved over Scala 2? If we talk about their improvements, then the biggest improvement that we have in Scala 3 is around the improved error messages that the compiler reports. The error messages in Scala 3 are way more helpful and meaningful and easy to understand. And if I show you an example, here we see an example of not having a given instance in scope. So we are calling a method foo, and the required context parameter cannot be found. So the compiler reports the error. It also suggests ways to fix the error and what options we have. The error messages say that we can import any one of the givens. So the error message is not cryptic, it's not a machine generated or looks like human friendly message, and that's a big win, right? For those who are learning the language, it's really helpful that the compiler is giving such human friendly messages. So that's a big improvement around having nice error messages. The other improved thing about given instances is the improved syntax for imports. The given instances in Scala 3 have a new syntax for import, and it's quite helpful. Let's look at an example to understand this. So we have an object A, and it has some normal properties like an integer, and it also has some givens inside it. Now, if you look at object B, in B we are doing a dot wildcard import, and that wildcard import will bring all the properties of A except the givens. So you can no longer hide your implicits behind a wildcard import, which is really helpful because a wildcard import will bring a lot of things, and implicits might be something that you really want to be sure when you're bringing into scope. So the wildcard import will only bring other properties but not the givens. If you look at object C, then we are having a special syntax for importing givens from a object. So we have import a.given, and this will import basically all the givens inside an A, including the ones that are not named. So anonymous givens will also be imported with this syntax. So in object C, you see the new syntax of importing only the givens, and if you want, you can combine them both. So in object D, we are combining both. We are combining an import to get everything given and everything non-given as well. So there are two main benefits of this new import syntax. The first important benefit is that things are really clear, what is coming from scope where, and it really enables you to import givens also without importing anything else. So there are two advantages, and both of them are quite important to have. So now with these changes in Scala 3 around the using clause, the givens, and the extension methods, our favorite work, which is implementing type classes, becomes a lot easier now. If you have to implement type classes in Scala 3, the syntax is quite concrete, it's easy to understand, and we can look at an example. But just to make sure you all are aware, type classes is basically an idea that lets you add new behavior to a type without subtyping, so also known as ad hoc polymorphism in Scala. So you are trying to add a behavior to a type that is not in your control, it's outside your code boundaries or it is closed. So how do you add new behavior? So let's look at that. First, the behavior. What behavior do I want to add? So that's a trait first. In my example, the idea is that given any type A, I want to create a response from that A. So in Scala 3, you would have a trait, and you would write an extension method, which is basically the behavior you want. So we define a response trait and an extension method on it that takes an A and returns an HTTP response. So that's the idea. That's the type class idea, basically, which is shown using a trait and an extension method. Next, we need to provide the implementations for our idea. So here I have provided two anonymized implementations using givens. So I have an implementation using string, and I have an implementation for int. Again, the details are not important. It's just that you can use givens to define instances of these traits, and you can override the extensions. Once you have specific givens for some types, you can use the existing givens to generate new instances. And that's the key here, that you can use existing types to generate new types. So if you see the example, what we want to do is we want to use an HTTP response of type T to generate an HTTP response of type option of T. And that's what that opt_r is basically doing. It basically says that if there is an HTTP response of type T available, then I can summon it, and summon is basically the new keyword for the same method implicitly in Scala 2. So I can summon the type class for T and use that for deriving the type class for option of T. And you can see that in the given statement, I'm using a context bound, and that is also nice. So you can use givens with context bound, and that is basically the rule saying that there must be a type of HTTP response of T for a given of HTTP response of option of T to exist. And that's basically how you can generate new types from existing types with this given keyword. And that is it. Once we have our implementations, once we have the type class, we can just use them to the idea that we had, that given any type, we want to generate a response out of it. So, and that's all working fine. So if I have to do a summary of what was there in Scala 2 and what was there in Scala 3, and if I do it by use case, so the use case of automatic resolution by compiler, basically in Scala 2, everything was done using the keyword implicit, but in Scala 3, we have different keywords and different syntaxes of achieving different use cases. So I hope all the authors will change their books. Most of the important ones have already. They don't mention implicits anymore, and the focus is more on these new keywords. So in Scala 3, the goal is, you have a use case, and you have a separate keyword or a separate syntax for it. So if the use case is to synthesize new terms, then you use the keyword givens. If the use case is to pass parameters silently or pass parameters that are never changing, then you use the keyword using. If you want to add new methods to types, you use the keyword extensions. And of course, if you want to create new type classes, then it's a combination of these keywords. So some final thoughts on this. Again, the biggest hope I have is that it becomes easy to learn. I think Daniel mentioned about the barrier, the entry barrier for people trying to learn. The stack, it's not just Cat's effect stack or Zio stack, it's also some inbuilt Scala things that are difficult to learn. And one of them was around contextual abstractions. So it really is a hope that things becomes easier to learn. And if it's easier to learn, then there is less chance of misuse, zero anti-patterns, and then adoption becomes easier. So I really hope this is the way it goes, and that's the idea of the designers as well. And that is all I had to share for my talk. So thank you, everybody. Thanks.
OK, thank you. We can try and ask one question if there is any. Or you can, OK.
Just a quick question. Just now there was a discussion that strings should not be implicit, should never be implicit. So can strings be given?
No, the ideally should never be.
But is that allowed?
It is allowed. So that's sort of the misuse that can be done. You can have an implicit defined as a string, and then you can pass it around. Ideally, it should not be done. And there are some toolings available to stop that kind of code going into your pipeline. So toolings will help here, but the library does not have any checks to disallow it.
But for givens, it does or does not?
It does.
Thank you.
OK, one more question. Can you go back to the slide when you use that type class? I just wonder, I think it's one more back. Do you have to do some imports to bring it in scope, or? Yeah,
you have to either do the import, or you can move these givens inside the object of HTTP response.
There's one slide when you use this extension method, right? You got string, and then there was a dot and response.
Yeah.
Do you have to use import there?
Yeah, I think here you have to use the import indeed.
Yeah, just import given. OK.
Yeah.
Thanks.
Yeah.
All right.
Thank you.
Ayush, thank you very much. It's been a pleasure having you here.